Welcome. In this lesson, we're basically just introducing that a quadratic equation, when you have a squared variable, a lot of times you will get two solutions to the equation if you try to solve it. Or if you do solve it, I mean, not just try, but you do. If q squared equals 81, what we do to undo the square is we square root. We square root both sides, but we need to remember that we can do that and get both a positive and a negative outcome. So in other words, we get a 9, but we can also get a q value of -9. Because what is 9 times another 9? Well, that's a positive 81. That made our equation true. But what's a -9 times another -9? That likewise comes out to be a positive 81. So we actually get two solutions, a positive 9 and a -9. And so when it comes to quadratics, we're going to get these multiple solutions. I don't know what that noise is. And why is this not? There we go. So again, we're going to square root 121. We get 11. But then we need to realize we also get -11. This one will probably go fairly quickly. We get 12. And we also got to remember we get a -12. We will eventually get to some that we actually have to rearrange the equations just a little bit. So we get a p squared equals, because what I'm going to first do is add 62 to both sides, add 62, and that's going to give me 70, 81. And then again, we find out our solutions are both a positive 9 and a -9. A positive 6 and a -6. Positive 9 and a -9. And the reason I knew that is, again, I just quickly added the 81 over, and if a b squared equals a positive 81, either 9 or -9 will multiply to give you 81. Here, you minus the 52 over, you get s squared equals 1 or -1, because both of those would square. All right, we eventually get to these where it's going to ask how many real solutions does the equation have. And the reason it asks that is it is possible to get a quadratic that doesn't have any real solutions. Because what would happen if I brought this 31 to the other side? I would minus it over. Minus 31, minus 31. And then I'm trying to find a number that squared gives you a negative outcome. But remember, a positive times a positive is still going to be positive, and a negative times a negative will still be positive. So there is no such real number that when you times it by itself is going to be a negative number. So if you end up getting an equation, a squared term equaling a negative number, you get no real solutions. The only way you get one real solution is if it equals 0. If z squared equals 0, then you'd have one real solution. If z squared equals a positive number, you get two real. So that's basically all you're doing. If you get your variable that's squared equals to a positive number, you get two real solutions. If you get z squared equals 0, you get one solution. And if you get z squared, or your variable that's squared equals a negative number, then you get no real solutions. Since 31 plus 21 is going to be a positive, I get two real solutions. Since I'm x squared equals a negative number, no real solutions. Since when I minus the 21 over, it's going to be a negative number, I get no real solutions. Here's the one where it's a 0. There's only one solution that works, 0. 0 squared is 0. Any other number wouldn't be 0, so that's one real solution. If you have any questions on this, please do bring in the class, and I will help you.